Assalamu alaikum. Today on 26 November 2024, I'm starting lecture number 1 for week number 11, and the topic of today's lecture is techniques of integration. So, as we all know, that integration is a process that is uh, taken as antiderivatives. So first of all, we will review some basic formulas that we already know from our FSC or A levels background, and then we will solve some particular integrals to elaborate the process of integration. So let us go through some basic formulas. uh, I already discussed these formulas with you before the midterm exam when we learned some basic techniques of integration. So it is just a revision of those formulas. If you recall, integral of x power n dx is equals to x power n plus 1 over n plus 1. तो अगर हमने x पावर 3 को इंटीग्रेट करना होगा तो वो x पावर 3 प्लस 1 over 3 plus 1 plus c के बराबर होगी. Similarly, if we are to integrate sin x, so obviously it is minus cos x plus c. Similarly, if we are to integrate cos kx, it is sin kx upon k plus constant of integration. We all know that integral of secant square dx is tan x plus cy because the derivative of tan x is secant square x. So if we are to take integral of secant square x, it will be tan x plus c. Similarly, formula number 6, integral of cosecant square x dx is minus cot x plus c. And integral of secant x tan x is secant x plus c. Why? Because the derivative of secant x is secant x tan x. Similarly, integral of cosecant x cot x is minus cosecant x plus c. Why? Because the derivative of cos x is minus cosecant x cot x. So integration is a process that is reverse of differentiation. So mostly if we differentiate a function and get a particular function, then the integral of that particular function is the given function which we differentiated at the first step. Okay, so that was a revision of some basic formulas. Now coming to particular examples. So in the first example, they are saying integrate x square. Okay, so we need to integrate x square. So how we will integrate this x square? It's very simple. If we are to integrate this x square, let me just solve it for you. इससे आप अंदाजा लगा सकते हैं कि कितने ऑनलाइन लेक्चर हो चुके जी. Okay, so if we are to integrate x square dx, so what we will do, we will add 1 to the power and then we will divide it with the same factor. So hence integral of x square dx is basically x power 3 upon 3 plus constant of integration. So it's a very simple procedure. If you are to integrate any power of x, it is that power plus 1 whole divided by that power plus 1 plus constant of integration. So we already did these uh, easy integrals earlier, but to make you understand this thing again and to revise some basic integrals, we are doing some examples. Okay, so coming to the next example, integral dx. Now sometimes students basically get confused when integrating dx. Now if we are to do this integral dx, it is just like integral 1 dx. Now 1 can be taken as x power 0. So it is written as x power 0 plus 1 upon x power 0, 0 plus 1. Then it will become x power 1 upon 1, that is x. So in short, if you are integrating with respect to x, so you will write integral dx, the answer would be x. If you are integrating with respect to y, that is integral dy, and nothing is inside, then the answer is y. If you are integrating with respect to t, like integral dt, the answer would be t. Okay?
सर इसके साथ आपके पास सी नहीं आएगा?
जी, हर एक के साथ कांस्टेंट ऑफ इंटीग्रेशन तो हर एक के साथ आएगा ना, ऑब्वियसली। ठीक है? But the main answer of the integral would be the variable with respect to which we are integrating. So integral dx is x plus c, integral dy is y plus c, integral dt is t plus c. Okay, so it's a very simple thing. Coming to the next example, they are saying integrate x power minus 5 by 4. So this time we are to integrate x power minus 5 by 4. Again, taking this integration of x power minus 5 upon 4 dx. So how we will integrate? Again, we will add 1 to the power, so it will become x power minus 5 upon 4 plus 1 whole divided by minus 5 upon 4 plus 1 plus constant of integration. So minus 5 by 4 plus 1, if we will take LCM, so it will become minus 5 by 4 plus 4 by 4. So it will become minus 1 by 4. So the answer would be minus 1 upon 4 upon minus 1 upon 4 plus C. Now this minus 1 by 4 in the denominator will become minus 4 times x power minus 1 by 4 plus C. So it will be the final answer of integration. Minus 4 times x power minus 1 by 4 plus c. Okay. So that is written here. Let me just make it a bit clear. Okay. Now coming to the next example where we are to integrate root of x plus cube root of x. Okay. So we are to integrate root of x plus cube root of x. Okay. Let me just adjust my camera. Okay. So integral of root of x plus cube root of x dx. If we are to integrate root of x plus cube root of x, so what we will do, we will simply write integral of x power 1 upon 2 dx, because root of x means x power 1 by 2, plus integral of x power 1 upon 3 dx. Again, because cube root of x means x power 1 upon 3. Now we will apply the power formula, x power 1 upon 2 plus 1 over 1 upon 2 plus 1. Similarly, for x power 1 by 3, the integral would be x power 1 upon 3 plus 1 over 1 upon 3 plus 1 plus constant of integration. Okay. So x power 1 by 2 plus 1 is basically 1 by 2 plus 2 by 2, that is x power 3 by 2. So it will become x power 3 upon 2 whole divided by 3 upon 2 because 1 by 2 plus 1 is again 3 by 2. Similarly, x power 1 by 3 plus 3 by 3 will be 4 by 3. So it would become x power 4 upon 3 upon 4 upon 3 plus constant of integration. Okay. Now this 3 by 2 will become 2 by 3 in the numerator. So we will write 2 by 3 times x power 3 by 2 plus 3 by 4 times x power 4 upon 3 plus constant of integration. So it would be our final answer. Okay. So you saw that integrating root of x plus cube root of x is again not a very difficult task. We can integrate this function easily. Okay. Now coming back to the question. So basically you can see that their answer is the same. Okay. Now example number 6. In example number 6, we are to integrate the product of x power minus 3 and x plus 1. So we are to integrate this thing. Okay. So how we will do this? Again, coming to our camera. So if we are to integrate x power minus 3 and the product of x plus 1 with it. So first of all, we will multiply. So x power minus 3 into x power 1 would be x power minus 3 plus 1. Similarly, x power minus 3 into 1 is x power minus 3 dx. Okay. Now x power minus 3 plus 1 is x power minus 2 plus x power minus 3 dx. Now we are to integrate uh, these two terms. So we will integrate them individually, and that is separately. So we will write integral of x power minus 2 dx plus integral of x power minus 3 dx. The integral of x power minus 2 would be x power minus 2 plus 1 over minus 2 plus 1. Similarly, the integral of x power minus 3 would be x power minus 3 plus 1 over minus 3 plus 1 plus constant of integration. So hence it would be x power minus 1 upon minus 1 plus x power minus 2 upon minus 2 plus c. And finally, we can write it like minus times x power minus 1 and minus 1 upon 2 times x power minus 2 plus constant of integration. So hence you can see that again it's not a very difficult task. We can easily integrate if two polynomials are multiplied with each other. So first of all, we will multiply them and then we will integrate them. Okay. Now I think these are very simple examples. So let us solve some difficult example. So let us solve example number 8. So in example number 8, we are to integrate the sine function. So the question is integral of minus 5 sine x dx. Okay. So if we are to integrate this thing, integral of minus 5 sine x dx. So it is very simple. We will apply the basic formula. First of all, we will take this minus 5 common. So it will become minus 5 times integral of sine x dx. Okay. Now, uh, obviously, integral of sine x is minus cos x. So it will become minus 5 into minus cos x plus constant of integration, minus into minus plus, and hence it will become 5 times cos of x plus c. So you saw that we basically use the basic formula that integral of sine x is minus cos x. And all other steps are very basic steps. So hence we integrated the function minus 5 sine x dx and got the final answer 5 cos x plus c. Okay. So I hope you understand these things because these are very basic formulas. Now coming to example number 9, where we are to integrate cosecant square x upon 4. Okay. So if we are to integrate cosecant square x uh, upon 4 dx, then what we will do, first of all, again, we will take this 1 upon 4 common, and hence it will become integral of cosecant square x dx. Now we know that the derivative of cot x is minus cosecant square x. So since the derivative of cot x is minus cosecant square x, therefore the integral of cosecant square x would be minus cot x plus c. So hence it will become minus 1 upon 4 times cot x plus c. So it was a very simple integral because we make use of the formula that d by dx of tan x is, sorry, d by dx of cot x is minus cosecant square x. So if d by dx of cot x is minus cosecant square x, then integral of cosecant square x will be minus cot x because integration is reverse of differentiation. Okay. Now coming to another example, example number 10. In example number 10, we are to integrate 2 upon 3 times secant x tan x minus cos of 2x. So we are to integrate this function in example number 10, 2 upon 3 secant x tan x minus cos of 2x. Okay. So how we will integrate this function? Again, we will uh, take this 2 upon 3 common. So it will become 2 upon 3 times integral of secant x tan x dx minus integral of cos 2x dx. Okay. Now since d by dx of secant x is secant x tan x, so integral of secant x tan x is secant x. So therefore, we can write it like since d by dx of secant x is equals to secant x tan x, therefore 2 upon 3 integral of secant x tan x would be secant x. Now for the second integral minus cos 2x dx, integral of cos x is sin x. So integral of cos 2x is sin 2x divided by 2 and then constant of integration. Hence the final answer would be 2 upon 3 times secant x minus sine 2x upon 2 plus constant of integration. So you saw that it is a very simple procedure. We can easily integrate basic functions using the basic formulas. In this question, we used two basic formulas. Integral of cos x is sin x and integral of secant x tan x is secant x. Okay. So again, let us confirm our answer. So you can see that uh, our answer is correct. 2 upon 3 times secant x minus sin 2x upon 2 plus c. Okay. So now coming to uh, example number 11. So in example number 11, we need to integrate sine square x dx. So again, we solve this formula, this question. So how can we integrate sine square dx? So for this purpose, we need to use a specific trigonometric identity. And what is it? It is basically sine square x equals to 1 minus cos 2x whole divided by 2. So this identity we will use sine square x equals to 1 minus cos 2x upon 2. So in place of sine square x, we will write 1 minus cos 2x whole divided by 2 dx. Because sine square x is equals to 1 minus cos 2x whole divided by 2. Now we will separate the two terms. So it will become integral of 1 upon 2 minus cos 2x upon 2. So we are to integrate these two terms. So in the next step, we will write it like 1 upon 2 times integral dx minus 1 upon 2 times integral of cos 2x dx. Okay. Now we know that integral dx is x, so it will become 1 upon 2 times x. And for the second integral, it will become 1 upon 2 times integral of cos 2x is basically sine 2x upon 2 plus constant of integration. So finally, it will become 1 upon 2x minus 2 into 2, 4. So 1 upon 4 sine 2x plus c. So hence the final answer is 1 upon 2x minus 1 upon 4 sine 2x plus c. So now again, if we confirm our answer from the given slide, so it is correct. Okay. Now coming to example number 12, where we are to integrate cos square x. Okay. So we are to integrate cos square x dx. Okay. So how we will integrate cos square x? Again, we will use a trigonometric identity, that is cos square x is equals to 1 plus cos 2x whole divided by 2. So in place of cos square x, we used a trigonometric identity 1 plus cos 2x whole divided by 2. Now again, we will separate the terms, so it will become 1 upon 2 plus cos 2x upon 2 dx. Now we will separate the integrals, so it will become 1 upon 2 times integral dx plus 1 upon 2 times integral of cos 2x upon cos 2x dx, sorry. Now we know that integral dx is x, so it will become x upon 2 plus 1 upon 2 times. Now integral of cos 2x is sine 2x upon 2. So hence our final answer would be x upon 2 plus 1 upon 4 times sine 2x plus c. So this will be our final answer. So again, we saw that using a basic trigonometric identity, we made integral of cos square x a bit easier because when we used this trigonometric identity, uh, everything become a basic function. So integration of a basic function can easily be done using a basic formula like integral of cos x is sin x or like integral dx is x. So whenever we use substitution, no matter it is trigonometric substitution or some other substitution, what happens that the integral becomes easier for us because as I told you before the midterm exam that the first technique that we will apply while performing integration is basically use of basic formulas. So if it will become a basic formula, we can directly quote the answer like integral of cos 2x we directly wrote it is sine 2x upon 2 because there will be no derivation, there will be no special technique like integration by parts or partial fraction, etc. because it is a basic formula. So for basic formula, we will directly write the answer of the integration. Okay, so coming to the next, first of all, if we confirm our answer, so you can see that our answer is correct 1 upon 2x plus 1 upon 4 sine 2x plus c. Now coming to the next integral, which is integral of 2 plus tan square x. So we are to integrate 2 plus tan square x dx. So how we will integrate this function? This time we want to integrate 2 plus tan square x. So it's very simple. First of all, we will convert this tan square x into secant square x minus 1. Again, we will use a trigonometric identity. So what happened that in place of tan square x, we wrote secant square x minus 1. Now we will simplify the function. So it will become 2 minus 1 plus secant square x dx. So now it will become 2 minus 1 is 1 plus secant square x dx. Now we will separate the integral, so it will become integral dx, or we can write integral 1 dx plus integral of secant square x dx. Now integral 1 dx is just integral dx, which is x, and integral of secant square x dx is basically tan x. Why? Because the derivative of tan x is secant square x. So the integral of secant square x is tan x plus c. So our final answer is x plus tan x plus c. So let us again confirm our answer from the given sheet. So if we go down, so you can see that their answer is also x plus tan x plus c. Okay. So now coming to another example, which is basically integral of cos x times tan x plus secant x. Okay, so how we will solve it? Again, we write this question. The integral of cos x times tan x plus secant x dx. So coming back to our so we are to integrate the product of cos x with 10x plus secant x. So first of all, we will convert everything in sin x cos x form. So 10x can be written as sin x upon cos x. Similarly, secant x can be written as 1 upon cos x dx. Okay. Now, when we multiply this cos x with the terms inside the bracket, what will happen? That it will become integral of sin x plus 1, because this cos x will eliminate these two cos x in the denominator. So now the question is very simple. It is integral of sin x plus 1 dx. So we will separate it like integral of sin x dx plus integral dx. So integral of sin x is minus cos x, while integral dx is x plus c. So final answer would be minus cos x plus c. So again, if we confirm our answer, so it is correct. Minus cos x plus c. Okay. So here what happened that we solved some integrals for you, uh, and we use some basic formulas that we already discussed before the midterm exam. So now let us solve some questions related to integration by parts. Okay, so for integration by parts, the first example given here is basically integral x ln of x dx. So how we will solve this question? Integral x ln of x dx. So again, as I told you before the midterm exam, we will take one term as u. Like for ln of x, we will take it like u equals to ln of x. And for x, we will write dv by dx equals to x. Now we will differentiate this u. So we will get du by dx as 1 upon x, because derivative of ln of x is 1 over x. Similarly, we will integrate this x, so it will become integral dv equals to integral x dx. So we will get v equals to x square upon 2. Okay, v equals to x square upon 2. Now what we will do, we will use the formula integral u into dv by dx is equals to u into v minus integral of du by dx into v dx. So this is the formula for integration by parts. Okay. Now we have taken u as ln of x, so we will write integral of ln of x, and for dv by dx we wrote x multiplied by x dx. So what would be the answer? So we will write u, that is ln of x, v, that is x square upon 2, minus integration, and in place of du by dx we will write 1 upon x, because du by dx was 1 upon x, and for v we will again write x square upon 2, because our v was x square upon 2. So for v we will write x square upon 2 dx. So hence x square upon 2 will be written as this. And obviously this x and this x power 2 will be simplified with each other. So it will become integral of x upon 2 dx. So finally, we will write x square upon 2 ln of x minus, we will take this 1 upon 2 common, integral x dx. So again, it will become x square upon 2 ln of x minus 1 upon 2. Integral of x dx is basically x power 1 plus 1 over 1 plus 1 plus c. So it will become x square upon 2 ln of x minus 1 upon 4 times x square plus c. So it will be our final answer. Okay. Now if we confirm this answer from the answer sheet, so you can see that the answer is also x square upon 2 ln of x minus 1 upon 4 x square plus c. So that was an example of integration by parts. Let us solve some another example. Okay, so x, now we are to integrate a function which is x into sine of x. Okay, let us solve this again on our answer sheet. So we are to integrate the
सर
product
वो
of
लड़का
x.
कह रहे कि लिंक सर
जी
वो साथ कह रहे कि लिंक वो पब्लिक कर दें, वो ज्वाइन नहीं हो सक रहा।
नहीं, लिंक पब्लिक ही है। लेकिन मैं जरा
सही
देखता हूँ, अगर मेरे मेरे पास वो वैसे आए हुए हैं तो मैं उनको एडमिट कर लेता हूँ। वो असल में
सही।
खुद एडिट नहीं होंगे ना उसमें, वरना लिंक
जी
तो पब्लिक है, वो कोई भी ज्वाइन कर सकता है। देखिए ना, आप में से किसी को मैंने एडमिट नहीं किया, सारे खुद ब खुद ज्वाइन हुए हैं, क्योंकि मैंने वो ऑप्शन ही खत्म कर दिया। जो भी लिंक को क्लिक करेगा वो अंदर आ जाएगा। वो मुझे लगता है उनके कोई उसमें मसला हो। देखिए ना, अब यहाँ 13 लोग हैं, मैंने इनमें से किसी को भी एडमिट नहीं किया, ये खुद ही सारे के सारे एडिट हुए हुए। ठीक है, तो लिंक
सही
पब्लिक
हो
है
गया।
ऑलरेडी। ठीक है,
ओके
अच्छा जी। Coming back, so we are to integrate the product of x sine x, x and sine x, with basically x sine x dx. So again, we will take one function as u. So we will take x as u. So we will write u equals to x. Then we will differentiate this du. So we will find du by dx. So the derivative of x is 1. Similarly, we will take dv by dx as sine x. And then we will integrate this dv. So integral dv will be integral sine x dx. So integral dv will be v, and integral sine x will be minus cos x. So now we will use the formula for integration by parts, that is integral of u multiplied by dv by dx is equals to u into v minus integral of du by dx multiplied by v dx. So for this formula, what we will do, we will basically uh, take u as x, dv by dx as sin x. Now in the answer, our u is x, our v is minus cos x, minus an integration from formula. And in place of du by dx, since du by dx is 1, so we will write 1 multiply by v, v is minus cos x dx. So it will become minus times x cos x, And this minus with this minus, it will become plus times integral of cos x dx. So again, minus x cos x. Now integral of cos x is sin x plus sin x plus constant of integration. Uh, I think this question was given in your midterm exam as well. So you can see that it is a very simple question, and we can easily use integration by parts to solve this integral. Okay, so I think we did a lot of examples today. So inshallah, we will continue this integration techniques portion uh, in the next classes as well. And our final objective is basically to calculate areas under the graph, areas between the graph, and similarly volumes of surface of revolution that are uh, basically covering at least 1.5 question of your final term exam. So for those areas and volumes calculations, we must be competent enough to solve any integral, no matter it requires integration by parts or substitution or reverse substitution or partial fraction. So first of all, we will take grip on these techniques of integration, that are substitution method, trigonometric substitution, reverse substitution, partial fraction, and integration by parts. And then we will solve those exercises where we will use these techniques to find areas under the graph, areas between the graph, and volumes of surface of revolution. So inshallah, in the next class, we will solve some more questions for you. If you have any query, any question, you can ask it right now. And we will take attendance after closing, after stopping this recording. Okay? जी स्टूडेंट्स, कोई सवाल, कोई चीज जो आपको समझ
नो
ना
सर।
आई हो? समझ आ रही थी सारी चीजें?
बिल्कुल सर।
क्या- जी, समझ आ रही थी? बता दें।
Yes, sir.
जी सर।
ओके, इट्स गुड। चलिए इंशाल्लाह रिकॉर्डिंग स्टॉप करते हैं और उसके बाद आपकी अटेंडेंस लेते हैं। ओके, अल्लाह हाफिज।